This lesson is on the properties of logarithms. We are going to look at how our properties of logarithms relate back to our properties of exponents. So a lot of times we have our properties of exponents memorized, and when we compare those, it helps us to remember the properties of logs. So here we go. We're going to use the change of base formula. And that is when we don't have access to a calculator or a computer program that allows us to put bases in that aren't 10 or e. So whenever we have log written, so if I have log of x, that is an automatically assumed log base 10 of x. We don't have to write the 10 because that is assumed. And then most of our calculators also have the natural log, which is where we have base e. So the change of base formula allows us to figure out the value of bases other than 10 and e. Okay? Then we're going to use the properties of logs to rewrite and expand and condense logarithm expressions. So here we go. So this is the change of base formula, and a lot of times we use the change of base 10, and the change of base e. There's really no reason to use something other than 10 or e, because if we had the ability to put in our calculator a base other than 10 or e, then we wouldn't need to be changing the base. We could just figure out the log as it is. So here we are going to use base 10 and base e for both of those. And this is something that you'll have access to for your test. You'll have access to these formulas, so you don't need to worry about having this memorized. So the change of base formula allows us to calculate logs when they are in a different base. So let's do this one. So I have log base 4 of 25. Log base 4 of 25. So what we can do is we can do log of base 10 of 25, and we don't have to write that base 10 in there because that's automatic, over log base 10 of 4. Now, here we are using log base 10. If we wanted to use the natural log, we could do the natural log of 25 over the natural log of 4. And remember, that's ln. Natural log is ln. One of the things that we definitely need to talk about are calculator keystrokes. I want you to be sure that you're entering it into the calculator correctly. That's a huge thing that we've got to make sure that we're focusing on. So what I want you to do is pull out your calculator, okay? And then we're going to do base 10 first. So I am going to put a parenthesis around my log of 25. So I'm going to start with a parenthesis, and then I am going to put log, and as soon as I hit log on my calculator, it puts a parenthesis. You don't have to put that. It puts it automatically. And so I am going to put log of 25 inside the parenthesis for my log. Then I've got to put another parenthesis. So let's look at what that's doing right here. This parenthesis is closing in the 25. So you have a parenthesis around the 25. Then you also have a parenthesis around the log of 25. So I want you to see right there exactly what's going on. Then this right here means division. Okay. Then we are doing log. And when you hit log on your calculator, you're going to get that parenthesis of 4, and then we have 2 parentheses that we have to close. Okay? Traditionally, we always round to 4 decimal spaces. So my answer to this is 2.3219. Now, as you are doing those with your calculator, be sure that you're focusing on the correct keystroke. Be sure you're rounding to the correct place. So look carefully at WebAssign to see what decimal space it wants to round to. Okay? Now, we're going to get the same exact answer when we do the natural log of 25 over the natural log of 4. Okay? So we would still put parentheses around the natural log of 25, and then I have to do a double parenthesis there. Okay? Then I am dividing by the natural log of 4, and we have a double parenthesis there. Okay? And we would get exactly the same answer. Okay? Now, I want us to talk some about the properties of logarithms. The properties of logarithms. So, exponents and logs are inverse functions, and so we are able to think about the corresponding exponential properties. So, I want us to look right here. I've got a to the u times a to the v. Okay, so let's think about this as a squared times a to the third. Okay, to solve that, we would add those two together and we would get a to the fifth. Okay, our log property, so here I am multiplying u and v together. Now this is base a, so my base has to stay the same. When I have that, I can separate that into log base a of u plus log base a of v. Okay, so we are going to learn about the product property, the quotient property, and the power property. And this is a good summary slide right here that has those properties written down. So, and it's the same with the natural log or a log. And typically, with our logarithms, actually always, you keep this base a, okay? You always keep whatever base you start with. So, our product property, here is our property, or product right here, u times v, and when we separate those, we add them together. Okay, our quotient property, here's our quotient right here, our base is a. When we separate those into two different logs, we subtract. Okay, then I have log base a, u to the n power. What we're going to do with that n is we're going to take it and we're going to stick it right there. Okay, so it's n times log base a of u. And when we solve equations, that property is going to be super important. So let's look at each one of the properties individually and work some problems out with these properties. Okay, this is our product property. This is our product property. So over here, I want us to think about our corresponding exponent property. So I have x squared times x to the third. I would add those two exponents together and I would get x to the fifth. This is the corresponding exponent property. Okay, so now I'm going to look at log base 6 of 2x. Okay, and very often you'll see that 2x in parentheses. So log base 6 of 2x. Log base 6 of 2x. So I am going to separate this. I am going to find log base 6 of 2, and then I'm going to find log base 6 of x. Okay? So I have log base 6 of 2, and I add that to log base 6 of x. Okay? Now, we could also have it as a natural log. We have to keep our base. Whatever base we start with, that's the base we have to continue with. So this is the natural log of x, y. So this x and this y are being multiplied together. So I have the natural log, whoops, I turned that into an m, sorry about that. The natural log of x plus the natural log of y. Okay, so I am going to go to the quotient property. Now, if we think about our exponents, if I have x to the fifth over x squared, I subtract those exponents and I get x to the third. Okay, we're going to do that very similarly with our logs. So this is the quotient property. I have log base A of 5 over x. So I'm going to find the log of 5, and then I'm going to find the log of x, and I'm going to subtract those. So I have log base A of 5 minus log base A of x. Now, whatever is in the denominator, that is what's negative, okay? If it's in the denominator, it's got to have a minus sign in front of it, always. And that is sometimes something that students get confused with. So we will, I'll show you a couple examples with that, because that is something that students get confused with. So if it is in the denominator, it has to have a negative in front of it. Okay, so let's do a natural log one. We have a natural log of x over y. Okay, so then I have the natural log of x minus the natural log of y. Okay, that is our quotient rule. The next rule that we're going to look at is our power property. And if we think about that with exponents, we have to multiply. That's what we're doing. So I've got x squared, and I'm raising that to the third power. So when I've got an exponent raised to an exponent, I multiply. So I have x raised to the 2 times 3. X raised to the 2 times 3, and that is x to the 6th. Now, it looks a little different with our power property with logs. So if I have log base A x to the third, what I'm going to do is I'm going to take this 3 and I'm going to put it right there. Okay, so I have 3 log base A of x. Okay, and that, so what you're doing is you are multiplying 3 times the log base A of x. Okay, and again, when we're doing equations, which is what 3.4 is about, when we're doing equations, that comes in very, very handy. Okay, let's do another one. Let's do the natural log of y to the 5th. The natural log of y to the 5th. So what I'm going to do is I'm going to take this 5 and I'm going to put it in front. So I have 5 times the natural log of y. Okay, and so those are our log properties that we are working with this week, our log properties. So now we are going to find the exact value, and you have been doing this already. You've been finding the exact value already, and so we're just going to continue that. So I've got log base 2 of 32. Okay, so we are trying to figure out what this equals. Okay, and remember, anytime that we are finding the answer to a log, we are looking for the exponent. We are looking for the exponent. Okay, so the question that I'm asking myself is 2 raised to what number gives me 32. Okay, so that's how we write it in words. We can also say 2 to some power is equal to 32. 2 raised to some power is equal to 32. Now, we may not know that off the top of our head, but we do know that 2 squared is 4. And then we could keep going a little bit. 2 to the third is 8. 2 to the fourth is 16. So 2 to the fifth is 32. So my answer to this is x equals 5, because what I'm looking for is an exponent. I'm looking for an exponent. Okay, now I want to do another one, so I'm going to erase this. So go ahead and pause if you need to write this down. But I'm going to erase this because I want to do another one. So for this one, I've got log base 3 of 1 over 27. Okay, now I don't want you to use a calculator. Find the exact value of the logarithm without using a calculator. And this word exact right here means I do not want a decimal approximation. Okay, no decimal approximation. You can find the answer to this using the definition of a log. So the question that I'm asking myself, 3 raised to what power gives me 1 over 27. Okay, so I'm looking for an exponent. That right there is an exponent. Now, we may have to think about this a little bit more, okay? Because we've got the number in the denominator. So 1 over 27 is actually a pretty small number, okay? So because we've got that 27 in the denominator, we're really probably looking at a negative exponent. So we need to think about that. So I want to look at how I can rewrite 27. So I know that 3 times 3 is 9. So if this was 1 over 9, I could just put the 3 squared in the denominator. But it's not 1 over 9, it's 1 over 27. So I know that 3 to the third power is 27. So if I've got 3 to the third power in the denominator, I can rewrite that by moving that to the numerator, and I just make it a negative exponent. So the power that I am raising 3 to in order to get 1 over 27 is negative 3. So my answer to this problem right here is negative 3. Okay? Now be careful when you're asked to find those exact numbers. Be careful when you're asked to find exact, because I don't want any decimal approximations. I want the exact number. Okay? Here we go. Now we are going to be rewriting logs using the properties. Okay? And this is super important for 3.4 when we solve equations. That's why we're going to do it. That's why this is important when we expand and we condense. Okay, so we are going to start with a log base 4. So here we go. I have log base 4 of 5, x to the third, y. So the first thing that I'm going to ask myself is what operation is happening between all of these individual numbers or variables. And the 5 is being multiplied times the x to the third. The 5 and the x to the third is being multiplied times the y. So we are going to use the product rule first. We're going to use the product rule first. So if I have log base a of x times y, that's going to be log base a of x plus log base a of y. Okay? So I am going to use the product property, and I am going to write the 5, the x to the third, and the y separately. Okay? That's what I'm going to do right now. So I've got log base 4 of 5 plus log base 4 of x to the third plus log base 4 of y. Now, I am finished using the product property, okay? But I also need to use the power property, and that's if I have log base a x to the b power, that b gets moved in front of the log. So I have b times log base a of x. Now I only need to do that in one spot. The only place I'm going to do that is right here. Okay, my 5 and my y didn't have an exponent. So I've got log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. Okay, so I am expanding. That's all I'm doing. I am expanding these. Okay, now I'm going to use all 3 properties together. I'm going to use all 3 properties together. Okay, so x squared and y are being multiplied together. W is being divided, and I have a variable raised to a power. Okay, so I'm going to have to use everything for this. So the first thing that I'm going to do is I am going to separate each individual thing. So I'm going to have log base a of x squared plus log base a of y. Now, both of those are positive because they're both in the numerator. That's why those are both positive. Now, my w is in the denominator, so I am going to subtract log base a of w. Okay, so I used the product rule and I used the quotient rule. Okay, now I've got to go back and use the power rule, and that just goes right there. So I have 2 times log base a of x plus log base a of y minus log base a of w. Okay, and that is my final answer. Now, this next one I want to talk a little bit about. Okay, log base a of x squared over w times y to the third. Okay, now this right here typically confuses students. And the reason it confuses students is the w and the y to the third are being multiplied together. And you are correct. They are being multiplied together. However, both are in the denominator. Okay? They are both in the denominator. So both will be subtracted. Because they are both in the denominator, both will have the quotient rule apply to them. So you are going to use the quotient rule for both of these. The quotient rule. They're both going to be minus. Now, if we thought just for a second about x squared, if I wanted to move my w up, okay, if I wanted to move my w to the numerator, that would be a negative exponent. So it would be x squared times w to the negative 1. Then my y to the third would be y to the negative 3. Okay? So think about that when you're rewriting this. Okay? Both of those are going to be subtracted because they're in the denominator. So I want to make sure that we've got that and we really kind of process what that's saying. Okay? So I've got log base a of x squared. Okay, and that's positive because it's in the numerator and that's what I'm starting with. Minus log base a of w minus log base a of y to the third. Okay, so now I am going to deal with the power property. And I'm going to move this 2 to the front, and I'm going to move this 3 to the front. Okay, so I will have 2 log base a of x minus log base a of w minus 3 log base a of y. Okay, so again, just remember, both of these are in the denominator, and so both of them are applied to the quotient rule, and they will be subtracted. Okay, again, this is something that is going to be super important when we move my start doing equations. Okay, now just like when we were factoring and when we cancel, when we're doing rationals and when we're adding, you have to think of this x plus 1 as a unit. It can't be separated. That x plus 1 has to stay together. Okay, this is not part of your product rule. That x plus 1, that is a unit. You're going to think about that the same way that you would think about y. Okay, so this is using the product rule and it's using the power rule. So I'm going to go ahead and write this out. I will have log base b of x plus log base b of x plus 1 squared. Okay. Now I can use the power rule and put that right there. Okay. So I have log base b of x plus 2 log base b of x plus 1. And that x plus 1 must stay together. Think of this as an individual quantity. Okay? Don't try to separate it. Do not separate. Those binomials stay together. And that is as far as you can go. Right there. Okay. Now, we've got another expanding. Yeah, and so this uses square roots. So our next one, I have the natural log of 3x minus 5. So again, you need to think about that 3x minus 5 as a unit. We are not separating that 3x minus 5. Okay? So I'm going to put right here, do not separate. Now, earlier we talked about what the square root of x meant. So what we have to do here is we have to turn that square root of x into a rational exponent. The square root of x has to be turned into a rational exponent. So this becomes x to the 1/2. Okay? So the square root of x is x to the 1/2 power. Okay? So I am going to rewrite this as the natural log of 3x minus 5, and that is raised to the 1/2 power, and that is over 7. So now that I rewrote that, I can go ahead and split it up. Now remember, this part right here, this is going to stay together. Okay? That 3x minus 5 is a quantity. We're not going to separate that quantity. Now the 1/2, we can do different things with the 1/2. Okay? So I'm going to have the natural log of 3x minus 5 to the 1/2 power minus the natural log of 7. Okay? Now, just because this is 1/2 doesn't mean I can't move it in the front. Okay? I can still do that. I can still move that in the front. Okay? So let's move that exponent. So I'm going to have 1/2 times the natural log of 3x minus 5. We are keeping that together. It's a quantity. It's being added and subtracted. You don't change that. Minus the natural log of 7. And that is as far as we can go. Okay? Let's look at our next one. We've got the natural log of a times b, and that quantity is raised to the 3rd power. So what I want to look at first is I want to look at this quantity right here raised to the 3rd power. So what we've got to do with this AB inside parentheses raised to the 3rd power is we have to use some of our exponent rules to deal with that. Okay, so we're not using log rules right now, we're using exponent rules. And I can rewrite this as the natural log of a to the 3rd power times b to the 3rd power. Okay, so I just gave this 3 to both of those because they are multiplied together and they are being raised to that power of 3. Okay, now that I've dealt with those exponents, now I can deal with my natural log. So I've got the natural log of a to the 3rd plus the natural log of b to the 3rd. Now I'm going to take this 3 and I'm going to move it to the front on both of them. So I have 3 times the natural log of a plus 3 times the natural log of b. Okay? Okay, now we're going to do some condensing. I have my product property, and then I have my quotient property. Okay, very straightforward, very simple. Now, when you rewrite these, when we are condensing and we are rewriting, you only have the log written once. Log is only written once. Okay? The log is only written once. You don't write it twice. Okay? It's the x and the y that are being multiplied together in one single log. So to rewrite this, I am going to have log base 6 of x times y. Okay? And it's reasonable to go ahead and put parentheses around that. Okay? Log base 6 of x times y. Okay, so I only have log base 6 written once. I only have it written once. Okay, we're going to do that again, but we're dividing. So I have log base 6 of x over y. So this x is divided by this y, and I only write log base 6 once. I only write it once. Okay? Now what we're going to do is we're going to put some exponents in there. So we're going to take this idea and we are going to put some exponents in. Okay? So what I would recommend that you do is you do this in 2 different steps. Okay? Don't try to do it all at once. Do it in 2 different steps. So the first thing that I want to do is I want to take this 3. Whoops. Okay. I'm going to take this 3 and I'm going to make it an exponent on that x. Then I'm going to take this 2 and I'm going to make it an exponent on that y. So I'm keeping everything else the same. I'm not writing it as a single logarithm yet. Okay? I'm dealing with the 3 and the 2. So I have log base 6 of x to the 3rd power plus log base 6 of y to the 2nd power. Okay? So now I have dealt with my exponents. Now I'm going to write as a single log. And because I've got addition right there, that means the x to the 3rd and the y squared are being multiplied together. So again, I'm only writing the log base 6 once. And I have x to the 3rd times y squared. Okay? Log base 6, x to the 3rd times y squared. Okay. Now I'm going to do the same thing with this one. Okay. The first thing I'm going to do is I'm going to rewrite it with my exponent. I'm still going to have it as 2 separate logs. So I have log base 6 x to the 4th power minus log base 6 y to the 3rd power. Okay, now that I have that done, I am going to do the division. Okay, because I am subtracting these, that means the x to the 4th and the y to the 3rd is being divided. So I have log base 6 x to the 4th over y to the 3rd. Okay? So, this is lesson 3.3. Good luck on your homework, and let me know if there's anything I can do to help.